In today's session, we are going to discuss about the very interesting topic from the GOC. GOC means General Organic Chemistry. GOC itself is a very interesting, important and easy concept, and GOC is considered as a heart of the organic chemistry. So from this topic, in today's session, we are going to discuss about the important concept that is nothing but the resonance. So let us start the resonance. रेजोनेंस, ये रेजोनेंस क्या होता है, कब होता है, कैसे होता है, कहाँ होता है, इसकी रिक्वायरमेंट क्या होती है, ये बहुत सारे क्वेश्चंस आपके मन में आते होंगे. तो लेट अस डिस्कस ऑल दिस क्वेश्चंस इन अ वेरी इजीएस्ट वे. राइट, बेसिकली ये जो कंसेप्ट है रेजोनेंस का, ये कंसेप्ट है प्योरली हाइपोथेटिकल है. This concept of resonance is a hypothetical one. We don't know whether in reality this will happen or not. It is a only hypothetical process, right? To explain the phenomenon of resonance, I will give some examples. Now I will draw the structure for the methane here. This is structure for the methane having molecular formula CH4, right? This is methane molecule. Now I am going to draw here the two structures for the benzene. Some students will draw the structure of benzene like this. Some other students may draw the structure for benzene like this, right? Okay, now see, if we want to study all the physical and chemical properties of this methane, then this only one structure of methane can explain all the physical and chemical properties of the methane. Means 100% properties, 100% physical and chemical properties of this methane can be explained by this structure. There is no any other structure possible for the methane. All over the world, no matter whether it will be England, it will be America, it will be Japan, there is only one structure for the methane, and this structure of methane can explain all the physical and chemical properties of this methane. But what will happen when we consider the example of benzene? These two are the structures of benzene, and these two structures are looking very similar to each other, but these two structures are not similar to each other. Now let us see how. Here, how many total carbons? 1, 2, 3, 4, 5 and 6 carbons. Here also 6 carbons. You know the molecular formula for benzene is C6H6, right? How many single bonds are here? 1, 2, 3. I am considering the single bonds only between the carbon. C single bonds are here 3 single bonds. Here also C single bonds, how many? 3 single bonds. CC single bonds are how many here also? 3. And what about the double bonds? 1, 2, 3. Double bonds. CC double bonds are here how many? 3 double bonds. And here CC double bonds, here also 3 double bonds. Means 3 single bonds are here and 3 double bonds are here. These two structures are looking very similar to each other, but these two structures are not similar to each other. देखते हैं कैसे? देखो, ये मैं नंबरिंग देती हूँ कार्बन को. This is carbon number 1, carbon number 1, and second. This is 1 carbon. This is second. This is third. ये 4th, ये 5th and ये 6th. चलो यहाँ भी नंबरिंग देंगे 1, 2, 3, 4, 5 and 6. Now look at these two carbons, carbon number 1 and carbon number 2. Here is a double bond. Here is a double bond. In between the same carbon numbers 1 and here is a single bond. Here in this case carbon number 2 and carbon number 3. Here is a single bond, and here in between the carbon number 2 and 3, here is a double bond. Here in between 3 and 4, double bond. Here single bond. Means double and single bond की position क्या है यहाँ? Different है. So these two structures are not similar. These two structures are different structures. Okay. Now out of these two structures, no any one structure will explain all the properties, that is the physical properties as well as the chemical properties of benzene. 100% properties of benzene cannot be explained by anyone, either this or either this. Any one structure cannot explain all the properties of benzene. Means about 90% properties will be explained by these structures, but not 100%. 100% properties of benzene cannot be explained by either of these two structures. Now why we will see here. This carbon, single bond carbon की बॉन्ड लेंथ कितनी होती है? 1.54 एंगस्ट्रॉम होती है. कार्बन डबल बॉन्ड कार्बन की बॉन्ड लेंथ होती है 1.34 एंगस्ट्रॉम, एंड कार्बन ट्रिपल बॉन्ड कार्बन की होती है 1.20 एंगस्ट्रॉम. ये है बॉन्ड लेंथ. नाउ दिस इज द बॉन्ड लेंथ ऑर्डर ऑफ सीसी बॉन्ड. सीसी बॉन्ड सिंगल, डबल एंड ट्रिपल. ये क्या है? ये सिग्मा बॉन्ड है. ये क्या है? इसमें एक सिग्मा बॉन्ड है, दूसरा पाई बॉन्ड है. इसमें एक सिग्मा बॉन्ड, दो पाई बॉन्ड्स है. सो व्हाट विल बी द बॉन्ड ऑर्डर? दिस इज द बॉन्ड ऑर्डर, सॉरी बॉन्ड लेंथ ऑर्डर. This is having greater bond length than this and then this. What will be the order for the bond strength? Bond strength and bond length are inversely proportional. See, bond strength is inversely proportional to the bond length, right? Bond strength is inversely proportional to the bond length. So if this is the order for the bond length, then what will be the order for the bond strength? Bond strength की order क्या होगी? Bond strength की order होगी reverse होगी. Bond strength की order क्या होगी? Reverse होगी. So ये बॉन्ड क्या होगा? स्ट्रॉन्गर होगा. ये बॉन्ड थोड़ा सा वीकर, और ये ऐसा. So this is the order for the bond strength and this is the order for the bond length. Bond length increases, bond strength decreases. Bond length decreases, bond strength increases. Like this. This is about the bond length and bond strength order. Now we'll see. Now we'll compare these bond length values here. This is a single bond. ये क्या है? आप सिंगल बॉन्ड है, पता है? ओके. तो इसकी बॉन्ड लेंथ कितनी होनी चाहिए? 1.54 एंगस्ट्रॉम होनी चाहिए, बिकॉज सीसी सिंगल बॉन्ड की बॉन्ड लेंथ क्या होती है? 1.54 एंगस्ट्रॉम होती है. तो इसकी बॉन्ड लेंथ होनी कितनी चाहिए? 1.54 एंगस्ट्रॉम होनी चाहिए. और ये है डबल बॉन्ड. इसकी बॉन्ड लेंथ कितनी होनी चाहिए? 1.34 एंगस्ट्रॉम होनी चाहिए. बट it will not happen. In this case also, all if we consider this double bond, this single bond, this double bond, this single bond, then the single bond की वैल्यू ये नहीं आ पाती और डबल बॉन्ड की भी वैल्यू ये नहीं आ सकती. हाँ, what is the reason? If we consider the experimental data, then it is found that all the CC, this carbon 1, 2, carbon 2, 3, carbon 3, 4, all CC bond lengths are equal in case of benzene. All the CC bond lengths are equal in case of benzene, and CC bond length in benzene is found to be 1.39 angstrom. 1.39 angstrom. इसका मतलब है ये वैल्यू जो है ये क्या है? 1.54 से क्या है? कम है. 1.54 से ये वैल्यू क्या है? कम है. एंड 1.20 से ज्यादा है ना? तो इसका मतलब क्या होता है? ये बॉन्ड लेंथ ना ही 1.54 है और ना ही ये 1.34 है, बल्कि ये बॉन्ड लेंथ सभी कार्बन की बॉन्ड लेंथ क्या है? यहाँ इक्वल है. All CC bond lengths are here equal, and the value is found to be how much? 1.39 angstrom. इसका मतलब होता है ये ना ही कंप्लीटली सिंगल बॉन्ड है 100% और ये ना ही 100% डबल बॉन्ड है। इसमें कुछ डबल बॉन्ड कैरेक्टर है, इसमें कुछ सिंगल बॉन्ड कैरेक्टर है। तो ये सभी बॉन्ड्स क्या है, इक्वल है। ये सभी बॉन्ड्स क्या है, इक्वल है। सभी बॉन्ड की बॉन्ड लेंथ क्या है, इक्वल बॉन्ड लेंथ है, राइट। सो these two structures are not similar because their double position of double bond is here different. And what is the CC bond length? CC bond length is equal, right? Now see here. बाद में साइंटिस्ट ने क्या किया है, ऐसा एक स्ट्रक्चर ड्रॉ कर दिया है, ये वाला स्ट्रक्चर। This structure is also a hypothetical structure. This structure of benzene is also a hypothetical structure, right? But it is considered as a real structure. This is also hypothetical. These two structures are also hypothetical structures, but this structure is considered as a real structure of the benzene. Now these two structures are the resonating structures of each other. This symbol, double-headed arrow, is a symbol for the resonating structure, and this symbol is for the resonance hybrid. It is a resonance hybrid. This symbol and this structure, it is called as a real structure. This is a real structure of the benzene. डिफरेंट साइंटिस्ट ने क्या किए, डिफरेंट स्ट्रक्चर्स दिए हैं। एट डिफरेंट टाइम डिफरेंट साइंटिस्ट गिव डिफरेंट स्ट्रक्चर्स फॉर द बेंजीन। आई एम गोइंग टू ड्रॉ हियर द स्ट्रक्चर्स, डिफरेंट स्ट्रक्चर्स फॉर द बेंजीन। अलग अलग साइंटिस्ट ने क्या किया है, अलग अलग बेंजीन के स्ट्रक्चर्स दिए। उनमें से कुछ स्ट्रक्चर्स मैं ड्रॉ करने की यहाँ कोशिश कर रही हूँ। देखिए ये जो दो स्ट्रक्चर्स है ना, these two structures are given by the scientist Kekulé. These two structures are called as Kekulé structures, right? Kekulé structures. Now these structures, there are three structures. Here are the three structures. Are called as a Deva structures. These three structures of benzene are given by the scientist Deva. These structures are given by the scientist Deva, and these two structures are given by the scientist Kekulé. These are the Deva structures. And all these structures are called as, all these two and these three structures, all these structures are called as resonating structures. Resonating structures is represented as a RS. These are the resonating structures. These are also called as a canonical structures. Canonical structures represented as a CS. These structures are also called as a contributing structures. What? Contributing structures. Contributing structures also represented by are the Dewar structure. None of this structure or single structure will not explain all the physical and chemical properties of the benzene. These all structures are the resonating structures, and these are the arrows, two-headed arrows are present here. These are the symbols of the resonance. This double-headed arrow is the symbol for the resonance. This is the resonance. These all are the resonating structures, and this symbol, these all are resonating structures, and this symbol is for the resonance hybrid. This is for the resonance hybrid. Now I will draw here the structure for the benzene, that is the real structure of benzene. This real structure of benzene will be like this. This is the real structure of benzene. Actually, this is a real structure, and this is the representation of what? This is the resonance hybrid. It is a resonance hybrid. Resonance hybrid. This is the real structure. Now this is about the resonance. Resonance means there is a if two or more structures are required. Here, two or more structures are required to explain all the properties of the benzene. All the physical and chemical properties of benzene can be explained by two or more structures. Not any one single structure is responsible for all the properties of the benzene. And so now we come to the conclusion that what is the requirement of the resonance? What is the requirement of resonance? We will write the conclusion. Now see, when two or more structures are required, two or more structures are required to explain all the physical and chemical properties of a compound, then resonance will arise. So this is the concept behind the resonance. Not only single structure is responsible to explain all the physical and chemical properties of a compound, and if two or more structures are required to explain all the properties of the molecule, then there will be the resonance. The resonance will be occur. The resonance कब जन्म लेता है? जब दो और दो से ज़्यादा structures की requirement होती है to explain all the properties of the molecule or compound. Right? This is about the resonance. Now we'll see about the conditions for the resonance. ये resonance कैसे चेक करना? रेजोनेंस किस मॉलिक्यूल में होता है और किस मॉलिक्यूल में नहीं होता है? रेजोनेंस कहाँ होता है, कहाँ नहीं होता है, क्यों होता है, क्यों नहीं होता है, और ये चेक कैसे करना? तो ये क्या देखना है हमें? अब कंडीशंस फॉर द रेजोनेंस देखना है. और एक एग्जांपल मैं आपको यहाँ दे रही हूँ 1,3-ब्यूटाडाइन का एग्जांपल. 1,3-ब्यूटाडाइन. This is a 1,3-butadiene, right? This is 1,3-butadiene. 1 position 1, 2. This is 3, 1,3 position, right? This is a 4 carbon compound. Root word is but. Di means two double bonds are here, and in it is a alkene. Now here also this is a double bond. ये bond की bond length कितनी होनी चाहिए? This 1.34 एंगस्ट्रॉम होनी चाहिए. ये सिंगल बॉन्ड है, इसकी बॉन्ड लेंथ कितनी होनी चाहिए? 1.5 ये भी डबल बॉन्ड है, इसकी भी बॉन्ड लेंथ कितनी होनी चाहिए 1.34 एंगस्ट्रॉम होनी चाहिए, बट इट विल नॉट हैपन, इट इज बिकॉज ऑफ द रेजोनेंस, इट विल नॉट हैपन, इट इज बिकॉज ऑफ द रेजोनेंस। ये क्या होता है, ये डबल बॉन्ड को सिंगल बॉन्ड कैरेक्टर आता है, कुछ परसेंटेज ऑफ सिंगल बॉन्ड कैरेक्टर यहाँ होता है, कुछ परसेंटेज ऑफ डबल बॉन्ड कैरेक्टर यहाँ होता है, और कुछ परसेंटेज ऑफ सिंगल बॉन्ड कैरेक्टर फिर यहाँ होता है डबल बॉन्ड। मींस 100% डबल बॉन्ड इज नॉट देयर एंड 100% सिंगल बॉन्ड इज आल्सो नॉट देयर। They are contributing structures, they are undergoing resonance with each other, right? So what are the conditions for the resonance? Now we will discuss about the conditions of the resonance. There are two conditions for the resonance. Basically two conditions are there. One second. Conditions of resonance. Conditions of resonance. इसमें फर्स्ट कंडीशन है conjugation. Conjugation. And second condition है planarity. सेकंड क्या है planarity. Conditions conjugation and planarity. Now we'll see the first conjugation. Conjugation देखते हैं, conjugation किसे कहते हैं। अभी हमने 1,3-ब्यूटाडाइल का एग्जांपल देखा था ना, ये 1,3-ब्यूटाडाइल का एग्जांपल देखा था, और कुछ एग्जांपल हम देखेंगे। अभी हमने बेंजीन का भी एग्जांपल देखा था, अभी हमने क्या किया था, बेंजीन का भी एग्जांपल देखा था ना। देखो ये रहा बेंजीन का एग्जांपल, और एक स्ट्रक्चर में यहाँ ड्रॉ करने जा रही हूँ, ये वाला, ये डबल बॉन्ड है 1 2 3 4, ये 1,4 डाई है, 1,4 डाई है। ओके, तो ये क्या है, ये डबल बॉन्ड, डबल सिंगल डबल, ओके, डबल सिंगल डबल, सिंगल डबल सिंगल। यहाँ क्या है, डबल सिंगल सिंगल डबल, मीन्स दिस डबल बॉन्ड्स आर not alternate. These double bonds are not alternate, but here in this example double and single bonds are alternate to each other. One double bond, single bond, double bond, double single double single double single. इसे क्या बोलते हैं, double bonds and single bonds are in conjugation with each other. What is conjugation? Double and single bonds are in a conjugation with each other. Now here are also double bonds, they are also 2 in number, but they are far apart from one another. They are not alternate with each other. There are 2 single bonds between the 2 double bonds. So the 2 double bonds are not conjugated. These are not conjugated. These double bonds are in conjugation. These double bonds are in conjugation. Okay. So conjugation क्या एक ही तरीके का होता है, डबल सिंगल डबल। हम ये जो चेन है ना, डबल सिंगल डबल की ये चेन, डबल बॉन्ड सिंगल बॉन्ड, डबल बॉन्ड सिंगल बॉन्ड, ऐसा हम ये चेन कितना भी एक्सटेंड कर सकते हैं, इस साइड में या इस साइड में। डबल सिंगल, ये क्या होना चाहिए, ये डबल एंड सिंगल बॉन्ड्स अल्टरनेट होने चाहिए। क्या है कॉन्जुगेशन खाली ओनली डबल एंड सिंगल बॉन्ड में दिखता है, ऐसा बिल्कुल नहीं है। और भी कुछ टाइप्स है कॉन्जुगेशन के, चलिए देखते हैं कितने टाइप्स है कॉन्जुगेशन के। सो टाइप्स ऑफ कॉन्जुगेशन, we'll see the types of conjugation. Types of conjugation देखिए, नंबर 1 CH2 डबल बॉन्ड CH सिंगल बॉन्ड CH डबल बॉन्ड CH2. Here is a conjugation, double single double, right? Double single double is a conjugation. सेकंड टाइप देखते हैं, CH2 डबल बॉन्ड CH सिंगल बॉन्ड CH2 प्लस डबल सिंगल पॉजिटिव। अनदर टाइप देखते हैं, चलो CH2 डबल बॉन्ड CH सिंगल बॉन्ड CH2 नेगेटिव, ये भी कॉन्जुगेशन हो सकता है ना। कॉन्जुगेशन विल बी बिटवीन द डबल सिंगल पॉजिटिव चार्ज, डबल सिंगल नेगेटिव चार्ज, और भी तो हो सकते हैं, देखते हैं चलो। CH2 डबल बॉन्ड CH सिंगल बॉन्ड CH2 फ्री रेडिकल, इसे क्या बोलते हैं? फ्री रेडिकल। ये अनपेड इलेक्ट्रॉन है, सिंगल इलेक्ट्रॉन, इसे क्या बोलते हैं? ऑड इलेक्ट्रॉन बोलते हैं। व्हाट इज दिस? दिस इज अ ऑड इलेक्ट्रॉन। नाउ वन मोर देखते हैं कॉन्जुगेशन का टाइप। CH2 डबल बॉन्ड CH सिंगल बॉन्ड CH2, दिस इज अ lone pair, or we can take this example NH2, this is a lone pair and this double bond, these two are in conjugation with each other, double single lone pair, double single free radical, double single negative, double single positive, double single double। तो ये क्या होना चाहिए? ऐसे अल्टरनेट होने चाहिए। Double bonds and single bonds are alternate to each other. Double bond and positive charge are alternate to each other. In the same way, double bond, negative double bond, free radical double bond, lone pair का और भी तो एग्जाम्पल हम दे सकते हैं। ये भी होगा, और ये ऑक्सीजन, राइट। There are two lone pairs present on the oxygen. Here double, single, lone pair। और भी तो एक हो सकता है 7th टाइप CH2 डबल बॉन्ड CH सिंगल बॉन्ड BH2, ये भी तो एक टाइप है कॉन्जुगेशन का। अब आइए देखते हैं इसकी तरफ। ये क्या है? बोरॉन है। बोरॉन इज इलेक्ट्रॉन डिफिशिएंट, राइट। दिस बोरॉन इज फ्रॉम द सेकंड पीरियड एलिमेंट, राइट। सेकंड पीरियड का एलिमेंट है। इसमें कितने सबशेल्स होते हैं? 2 सबशेल्स होते हैं, बिकॉज इट इज अ सेकंड पीरियड एलिमेंट, राइट। सो इसमें 2 सबशेल्स होते हैं, एक होता है S सबशेल और एक होता है P सबशेल। S में कितने ऑर्बिटल्स होते हैं? ओनली 1 ऑर्बिटल होता है S ऑर्बिटल। P में कितने ऑर्बिटल्स होते हैं? 3 ऑर्बिटल्स होते हैं। 3 ऑर्बिटल्स, एक PX होता है, PY होता है, PZ होता है ना। PX, PY and PZ, this is the S orbital, right। Now the hybridization of this boron is sp2 hybridization, 1 s orbital and 2 p orbitals undergo hybridization and then they form sp2 hybrid orbitals, right। sp2 hybrid orbitals। Now this one orbital is unhybridized, this orbital is unhybridized, this is a unhybrid orbital। This unhybrid orbital, it is vacant also, this orbital is a vacant। You have studied this concept of hybridization in the chemical bonding, right now? Chemical bonding, hybridization, the phenomenon of hybridization is also hypothetical, this is also hypothetical phenomenon। Now here the vacant orbital is there, unhybrid vacant orbital is present on the boron, and this vacant orbital, unhybrid orbital, is in conjugation with this double bond, double single, this vacant orbital, double single vacant orbital। Not only this, but one of the conjugation is also there, CH plus charge single bond, here OH and here lone pair, this plus and lone pairs, they are also in conjugation with each other। This is the concept regarding the conjugation, right? It is the conjugation, right? Now the next, that is the next condition. What is the next condition? It is the planarity. Next condition is the planarity। Here up till now we have studied about the resonance. What is the resonance? When it is required, okay, and how many are the structures of the benzene, Kekulé structures, Dewar structures, what they are called? They are called as the resonating structures, contributing structures, canonical structures, right? And what is the resonance hybrid, what is the real structure, all these things we discuss here। And we discuss here again the conditions for the resonance, that is one of the conditions we discuss here, that is the conjugation। conjugation means double single bond का alternate होना। not only double and single bonds, but double bond, positive charge, double negative, double free radical, double bond, lone pair, double bond, lone pair, double bond, vacant orbital, and plus charge lone pair. These all are the types of the conjugation. Next condition is a very important condition, that is the planarity. Now, if conjugation is there in the compound, then only it will show the resonance. Then only it will show the resonance. There should be a conjugation present in the compound. Conjugation का होना बहुत बहुत जरूरी होता है for resonance. अगर conjugation किसी compound में नहीं होता है तो वहाँ resonance भी नहीं होता है. अगर मैं ये स्ट्रक्चर ड्रॉ करूँ, ये ACH2OH, तो यहाँ लोन पेयर्स है. क्या यहाँ कॉन्जुगेशन है इस कंपाउंड में? लोन पेयर तो दिख रहे हैं हमें, लेकिन दिस लोन पेयर्स आर नॉट इन कॉन्जुगेशन विथ either double bond or with positive charge, right now, or with negative charge. So here is no conjugation. If conjugation is there, then that compound will show the phenomenon of resonance, right? चलिए आते हैं, देखते हैं सेकंड कंडीशन क्या है. सेकंड कंडीशन इज द प्लेनरिटी. सेकंड कंडीशन इज द प्लेनरिटी. मॉलिक्यूल कैसा होना चाहिए? प्लेनर होना चाहिए. मॉलिक्यूल कैसा होना चाहिए? कॉन्जुगेटेड होना चाहिए. कॉन्जुगेशन, एनी अदर टाइप ऑफ कॉन्जुगेशन विल बी देयर, बट क्या होना चाहिए मॉलिक्यूल में? कॉन्जुगेशन होना ही चाहिए. और रिगार्डिंग द प्लेनरिटी वी विल डिस्कस नाउ द second condition of the resonance, that is the planarity. There are two ways to explain the concept of the planarity. One is a very shortcut trick and one is a depth concept. I will tell you the short trick later on, but now I will discuss about the depth concept, but behind the planarity. Now see here, I will draw here the structure for the benzene. For benzene, benzene C6H6, 3 single bonds, 3 double bonds. Hybridization of benzene is sp2, right? Each carbon of benzene is sp2 hybridized. sp2 hybridized means 1s orbital. कार्बन का इलेक्ट्रॉनिक कॉन्फ़िगरेशन इन एक्साइटेड स्टेट क्या है? कार्बन का एटॉमिक नंबर 6. कार्बन इज हैविंग एटॉमिक नंबर 6. कॉन्फ़िगरेशन 1s2, 2s2, 2p2. In excited state, this one of the electron from the 2s get promoted to the 2p orbital. You might have studied all these things in the chemical bonding. Okay, this is 1, this is the 2, and this is the 3. Now this is s orbital, this is a px, this is a py, and this is a pz. Now this 1 s orbital and 2 p orbitals undergo hybridization to form a hybrid orbitals. Now this is a 1 hybrid orbital. Three hybrid orbitals are formed here. 1, 2, 3. 3 hybrid orbitals are formed, and this pz, this is a unhybridized pz orbital. All orbitals contain how many electrons? 1 electron each. All orbitals contain 1 electron each. Now these 3 sp2 hybrid orbitals, hybridization is what? sp2 means molecular is a planar. Molecule कैसा होना चाहिए? planar है. Trigonal planar structure for the sp2 hybridization. Okay, so it will have a planar structure like this. And what is the bond angle? Bond angle will be how much? 120 degree. Bond angle should be 120. So see here, this is a 120 bond angle. This is a planar structure. This carbon will form 3 bonds. Okay, one bond with this orbital, one bond with this, and one bond with this. Right? Three bonds. One carbon will form three bonds. This is one bond. This is the second bond. This is the third bond. This carbon also form three bonds. 1, 2, 3. This carbon will also form three bonds like this. The three bonds will be formed here, and each bond angle is a 120 degree. Right. Now this unhybrid orbital, it remains here. This, one second. This unhybrid orbital remains here perpendicular to the plane of the molecule. This will remain as a perpendicular to the plane of the molecule like this. This will remain. All carbon atoms, all 6 carbon atoms have unhybrid one orbital, and this unhybrid one orbital is a perpendicular to the plane of the molecule. This is a trigonal planar structure, right? Trigonal planar structure, and this unhybrid orbital is perpendicular to the molecular plane. This is a molecular plane. Now see. This is our benzene molecule. This is a molecular plane, and this pz orbital, which is an unhybrid orbital. This orbital is like this, perpendicular to the plane of the molecule. One lobe is at the back side of the board, and one lobe is in front side of the board. Suppose this is a plane of the molecule, and one is at the back side, one is at the front side. Right? This is the pz orbital, and these pz orbitals they will form the pi bonds, lateral overlapping से वो ये क्या करते हैं, pi bonds form करते हैं ऐसे. ये क्या करेंगे, कोई भी दो क्या करते हैं, lateral overlapping से क्या करते हैं, pi bonds form करते हैं. Right? So sigma bonds are formed by the hybrid orbitals. Pi bonds are formed by the what? Unhybrid orbitals. And कैसे होनी चाहिए unhybrid orbitals? Unhybrid orbitals should be perpendicular to the plane of the molecule. But all these unhybrid pz orbitals, they must be in a same plane. They must be in a same plane. Then and then only they can overlap laterally with each other to form a pi bonds. Right? This is about the planarity. So here we discuss about the concept of resonance, conditions for the resonance, and that is the conjugation and planarity. Some more methods of drawing are also there that we will discuss in the next lecture. So today we will stop here. Thank you and have a nice day.